All right, for Pre-Algebra Unit 2, Day 2, so 2.2, we're going to talk about fractions and then equivalent fractions. We're going to just skip right to the first example. So we're going to be identifying fractions. This one is asking what fraction is shaded. When we are looking at fractions, we are going to have a number on top, which is called the numerator, and then a number on the bottom, which is called the denominator. The number on the bottom, the denominator, is how many equal parts. Oops, that's not how you spell how. Sorry. In a whole. So in this shape, we have 1, 2, 3, 4, 5 equal parts, which makes that our denominator. The numerator tells us the amount of the equal parts that we are looking at. So for this one, we have 1, 2, 3 shaded parts. So our numerator would be 3. That makes our fraction 3/5. The important thing is when you are identifying fractions, the parts, when you are counting them, have to be the same size. If they're not the same size, you are going to have to do a couple extra steps to get the answer. All right, example 2. Go ahead. This one's asking what fraction is shaded. So if we see there are 2 shaded parts, and then there are a total of, I cannot count today. Sorry about that. There are 3, 4, 5, 6. Total of 6 parts. So for that, the shaded part is 2 out of 6. Is there more than one name you can give the fraction that is shaded? With this, there are a few different ways you can find equal parts in your picture. So if we were to group together 2 of them to make this one, another one, and then down here, our third part. So we could have split this into 3 instead of 6 pieces, and that would mean that we would have a shaded part of 1/3. And the way we could get that without the picture is by looking, 2 and 6 can both be divided by 2, and that gives us the fraction 1/3. Another thing that we could do, so if we started with 2 over 6, we could split it up into even smaller pieces. So we could split each of these into 2 equal parts. So then instead of having 6 total parts, we would have 12. And then of the shaded ones, we would have 4. So another way to get this is by taking our numerator and denominator and multiplying it by 2. So 1/3, 4/12, and 2/6 are all equal to each other. Okay. So some vocabulary, make sure if you need a lot of time, make sure you pause and write these down. We have equivalent fractions, and those are 2 fractions that represent the same number. So we just went over how 2/6 was equal to 1/3, and that was even equal to 4/12. All of those represented the same amount of shaded space in our picture and our diagram, which makes them equivalent fractions. And we talked about the numerator. That is the number of equal parts, the number on the top of the fraction. And then the denominator is the number of equal parts in a whole, the number on the bottom of our fraction. So if you need more time, pause. I'm going to move on to the next slide. Okay, example 3. What fraction is shaded? Is there another name for that fraction? So if we look at this one, not all of the parts are equal to each other. So we can split this one on the top, and now they're all the same size. That line wasn't very good. It doesn't have to be perfect, but if we were to add a line there, they would be all equal parts. So now we have a total of 1, 2, 3, 4, 5 parts, which means our denominator is 5 and only 1 was shaded. So 1 over 5 would be our fraction. To find another name for that, we could split these into 3 pieces if we wanted to. The last time we did 2, this time let's do 3. So if I split each of those into 3, there are now a total of 15 parts. And of those 15, only 3 are shaded. So another example of an equivalent fraction would be 3 over 15. And we could get that by taking the 1 times 3 and 5 times 3 to get 3 over 15. The important thing is that these numbers, when we're multiplying, both the numerator and the denominator have to be the same. All right, what fraction is shaded here? So if we make our equal parts, we would have 1, 2, 3, 4, 5, 6. So our denominator is 6, and our top number would be 1. This time, another name for the fraction, I'm going to choose a different number. I'm going to multiply by 5 this time. I'm not going to draw it because adding 5 lines would be a little difficult in this picture, so I'm just going to find it mathematically. And that would give us another fraction of 5 over 30. And both of these are equal to each other. Then example 5, again, we're going to make our fractions the same, or the parts the same size. And this time we have 4. So our denominator is 4, and there's 1 shaded. And to find an equivalent fraction, I'm going to multiply by 10. Again, the numbers just have to be the same on the top and the bottom. And that would give us 10 over 40, which is equivalent to 1 over 4. Right. Our next one, splitting them into equal parts, we have 1, 2, 3, 4, 5, 6 for our denominator, and 3 are shaded. This time we're going to go over a couple. If I look, I notice there are 3 white ones on the top and then 3 shaded ones on the bottom. So we could have split this into 2 groups instead of 6, making our denominator 2, and that would mean we would have 1 over 2 for another fraction. And that, mathematically, we get there by dividing both the top and the bottom by 3. That gives us 1/2. We could have also taken 3 over 6 and multiplied both of those by, I don't know, let's say 12. That would give us another equivalent fraction of 36 over 72. All right, sometimes our fraction bars will be sideways instead of horizontal or vertical. This one has 3, 4, 5, 6 parts, so our denominator would be 6, and there are 2 shaded. The first thing I notice is that I could make groups of 2 with these fraction strips. Oops, there we go. So then I would have 1, 2, 3 parts for my denominator, and only one of those parts was shaded. And we got there mathematically by just dividing both our numerator and our denominator by 2, giving us the equivalent fraction of 1/3. All right, for the video, we are going to skip this part. So I'm just going to scroll through this. Here we go. Okay, so now we have some examples in your note packet. Our next example are the fractions equivalent. So what we're looking for is, can we multiply or divide by one fraction by a number to get the other one? So if we look at our numerators here, we have 5 and 1. And I know 5 divided by 5 equals 1. So then we need to check on the bottom. 15 divided by 5, does that equal 3? And it does. So because both of these are divided by 5, that means, yes, they are equivalent. Another way we can do that is by simplifying our fractions. So if we had 5 over 15, I know both of those numbers could be divided by 5. So we could simplify them by getting the numbers to be as small as possible. And that would give us 1 over 3, which you'll notice is our other fraction. And 1 over 3 can't be simplified further because we can't divide both the top and the bottom by the same number and still have a whole number. All right, our next one. Are these fractions equivalent? If I look, looking at the numerator, the numerator, I don't know any numbers I can multiply 7 by to get 16 off the top of my head. So I'm going to look at my denominators first. 3 and 6. To get from 3 to 6, I know that is times 2. So I want to check, is 7 times 2, does that equal 16? Which it does not. That means no, these fractions are not equivalent because we did not multiply both the top and the bottom by the same value. Okay. Example 3, are these fractions equivalent? Now, we talked about looking at them. So we have a 4 and an 8. I know 4 times 2 equals 8. So now we need to check, is 6 times 2, does that equal 10? And that would equal 12. So no, these are not equivalent. Example 4, we can check the top. We have 3 and 12. I know 3 times 4 is 12. So I need to check, is 5 times 4 20? And it is. So that means, yes, these are equivalent. Okay. With these, sometimes you are going to be asked to find the missing value to make equivalent fractions. So we have 28 over 35 equals a number, this is what we're looking for, over 5. So we're going to look at the two values they gave us. So they gave us 35 on the bottom and 5. So I need to figure out 35 divided by what equals 5. And that's going to be 7. If you didn't know that, you can count by 5s till you get there. So now we're going to take this top number and we're going to divide that by 7 as well because we have to follow the same operation that happened on the bottom. So then 28 divided by 7, if we count by 7s, we would have 7, 14, 21, and then 28. That gives us the answer of 4. So you are finding the operation with either the numerators or denominators, whichever one they give you both of, and then you use that operation to find your missing value. All right, so if we look at this next one, we have 3 over 8 equals 6 over a number. They give us both the numerators, so we're going to find our connection between 3 and 6. And I know 3 times 2 equals 6. That means on the bottom, we are going to do that same operation times 2 to get our answer of 16. Then number 7, 15 over 20 equals 4 over a number. And 4 and 20 are related to each other because I know 20 divided by 5 equals 4. So then on the top, I need to take 15 divided by 5 to give us our answer, and that will be 3. Example 8, find the missing value and make equivalent fractions. This would be a great time for you to pause and try the problem on your own first. For this one, I know 7 times 4 is 28. So on the bottom, we have to take 5 times 4 to get our missing number. And that is going to equal 20. Okay. Some of these we are going to have a word problem for. So for example 9, you have a bag of candy. Out of the bag fell 8 candies. That is 2/3 of the bag. How many candies were in the whole bag to start? So for this problem, we are going to draw a picture. We know all inside of this, we have all of our candies. This is what we are looking for. We want to figure out how many candies do we have inside the bag. And they said 8 candies fell out, which is 2/3. So let's draw 2/3 inside of our bag. So we're going to split this into 3. And we know in this 2/3 there were 8. And each part has to have the same amount of candies. So we need to split that 8 into these 2 parts. So we're going to take 8 divided by 2. And that gives us 4. And if you didn't know that, you can put your dots there until you figure out that to get 8 candies, there are going to be 4 in each of them. Now remember we talked about fractions being the same size in each of the parts. So if there was 4 in each of these, that means there's 4 in that last part. Now we can figure out how many candies were in the whole bag to start by adding up all of these together. 4 plus 4 plus 4. And that gives us 12 candies. Okay, let's do number 9 or 10. So this one, you have a bag of candy. Out of the bag fell 9 candies. That is 3/5 of the bag. So this 9 is 3/5 of the bag. How many candies were in the whole bag to start? So if we draw a picture, we have 3/5. So if we need to divide this into 5. So we have 1, 2, 3, 4, 5 parts. And 9 candies need to be split into 3/5. So we're splitting this into 3 parts. So to figure that out, we're going to take 9 divided by 3. That means each of these parts had 3 candies. And remember, with fractions, all of the parts have to be the same. So that means these other parts that are still in the bag also have 3. Then to get the total amount of candies, we will add those up. 3, 6, 9, 12, 15. So in the whole bag, we have 15 candies. All right, that's where we are going to stop for today. For the practice, you are going to do an IXL. There we go. IXL F2, which is on equivalent fractions. You need a SMART score of 80. Make sure you ask questions if you need help or if you are just confused on anything. Have a good day.